Hello everyone, hello mates. Thank you all for coming today. It's always a pleasure to be here. Unreal Fest around all the other passionate Unreal nerds like myself. So welcome to my talk, Enhancing Digital Twins, Scriptable Tools, and Design Workflows for Crowds. Now allow me just to introduce myself to you all before I get started. So my name's Joseph Yong. I'm the lead Unreal developer at Squint Opera. Now I started my journey with Unreal about 13 years ago now. So I started as a games artist, and I went on to become a gameplay programmer. And it's this marriage between the technical and the creative that's really shaped the way that I approach tasks like building pipelines and tools and applications with Unreal. And that's really what today's talk is about. How can we build tools that are going to reduce friction, lower the barrier to entry, and allow us to spend more time focused on the creative tasks at hand and less on the repetitive and the remedial tasks that can come along with production. So as I said, I work at a company called Squint Opera. We're a sponsored service partner of what we're very proud, and allows me to be here to talk to you all today. But Squint is actually part of a larger collective that's called Journey. And this is a collaboration with many different talented design agencies that work in multiple different disciplines to create experiences for their clients, which we like to call multi-dimensional experiences. Now, this can be anything between stage shows to designing museums, virtual production, and digital twins. But we all live and breathe this stuff. And it's having access to leading experts in all these different fields that really allows us to innovate on what we do. And Squint Opera as an entity has been around for over 20 years now. So we have an expansive body of work in the cultural and the architectural spaces. But it's the last 6 years or so we've had a real focus on real-time and interactive applications. And it's Unreal Engine and digital twins that have become our bread and butter at the heart of it all. So this allows us to build cool stuff every day, and some of which I'm excited to share with you all today. So just to get us started, I want to just introduce some concepts and some terminology so we're all on the same page. And then I want to talk about our approach to tools. So today with Scriptable Tools, it's not about how to build them in blueprints. Like many other smarter people than me have already built those talks. So what we're going to talk about is our design approach and how we approach to UX to make these easy to use for all of our teams. And to do this, I'm going to give you a little demonstration of some tools we've been building over the last year or two, which focuses around creating optimized crowd characters for our large open scenes. And then finally, how you can do this too. So I want everyone to have a bit of a practical takeaway from this today. So there's an EDC post that I'm putting up at the end of the week as a companion post for this. And part of that, there's going to be some assorted resources for you all. So there's going to be a small code plugin that you can get that has a couple of utilities you can use to extend your own tools and just push scriptable tools a little bit further than what comes out of the box for the editor. And then some resource links. So anything that I can't fully get in depth with you all today, I'll post some tutorial links and creators and contributors that have been vital to my own learning with Unreal Engine. So let's dive in, and let's just say, what is a scriptable tool, right? So just to get a quick show of hands, like how many people here have actually built scriptable tools? Okay, so I've got a couple of dudes. Most people hands are down, so that's good. I'm not redundant yet. So a scriptable tool for the rest of you, what it does, it takes the interactive tools framework and exposes it to blueprints for us. So if you look at the documentation, they point towards the modeling toolkits, right? This is what an interactive tool could be. This isn't to say you get all of the geometry and modeling tools with this, but what it is, it's a framework that can sit on top of more complex tasks you've built, and you have a nice, easily dockable tool that lives in your tool palette, and it's just there to speed up our workflows and make our lives easier. So over the last couple of years where we've adopted scriptable tools into our pipeline, there's a number of benefits that we've come into. So the first one just being faster prototyping. So as I said, they've exposed this to blueprints now. And the real advantage of visual scripting from the beginning is just it's quicker to get your ideas down, right? We can hash this out, see what works, and work with it very quickly. And this leads into broader maintainability. So exposing these tools to the blueprints means that more people are able to come in and actually build tools for themselves. So previously, you would have needed a team of C++ coders to actually build these custom tools on the back end. But now we can have our tech artists pull this up and build tools that are driven for their own teams. And then finally, one thing that I think is really important with this is keeping your workflows in the editor. Now, this isn't to say that Unreal should or could do everything, although we're very close to it. But what it allows us to do is keep focused on the task at hand. So if we look back to when we all moved into UE5, there was a big redesign of the UI. And a big part of this was to keep you focused in the viewport with what you're doing, give you more screen space, stop us jumping around different applications. And we've all been there, like you've got a mesh, there's a hole, I've now got to export that as an FPX, and I've got to load another DCC, and I'm not going to name the name, but it takes like 10 minutes to open. I'm going to patch the hole in it and bring back in. And in that time, all I've achieved is I've kind of wasted my time, but I've broke that cognitive flow. It's taken me out of what it is that I've been trying to do. So we're going to keep ourselves in the editor, and Scriptable Tools empower us to do so. But although I love building tools and frameworks, we should always err on caution when we go in to build these things. We should consider ourselves, right? So there's a couple of questions I always ask myself and my team when we go to create these tools. So the first is just, what problem are we trying to solve? And really, this is saying, hey, do your homework. Let's check out what workflows already are documented and exist, what plugins are already in the engine that we may be able to take use of. Maybe it does 80% of what we need it to, but we can use Scriptable Tools as a framework to kind of massage those inputs and outputs into exactly what they need to be. So let's not reinvent the wheel. And then let's always keep in mind who's going to use this tool. Like, who is your end user? So this isn't to split the technical and the creative people in the room, but the way we look at problems can be very different. And the terminologies we use can also be very different. So let's make sure they're intuitive. A tool at its heart should be simple and easy to use and make our life easier. No one wants to go and study for 20 minutes to pick up a tool set that should be for a 30-second job. So let's make sure it's very easy and well communicated. And then finally, will it actually save time? So this is something I've been guilty of, and I'm sure a few of you may have done this too. You've got to scope your time into the task that's at hand. So for example, for us at Squint Opera, we don't have the liberties of 2, 3, or 4 year long project timelines. We work on more of a quarterly basis with our clients. We generally have about 2 to 4 months to ship a project. So this means if we have to factor in building a tool, it's not just like, hey, I need 3 days to build this. You need to QA this and make sure it's good before it goes into production. And also it must be documented, right? This is the whole point of a usable tool. And I would argue if you don't do those last 2 steps, you just have a fancy prototype and you're the only person who knows how to use it. So it defeats the point there. So let's make sure we can scope this all in and fit that in the window we're doing. Now, with all of that kind of laid out, I think it's a good point for us to start looking at this character tool set and have a little bit more interesting. So given NDAs and all the fun stuff that comes with private sector work, I can't show you our current production builds, but what we've done instead is we've got a nice asset pack from the Fab Store. It's a Roman town. I'll link to it at the end. But we've kit bashed together a scene to give our characters some context. So you can see how we lay out our characters, the approach about where do we put detail and why. So I've got a quick version of it here for you all to see. And we can see as it loads in here, we're going to see us overlooking a small plaza in a town. And we have people animated on rooftops. They're down in the cafes. We have people walking through the scene, introduce some motion. But what we try to do to break up repetition of characters is, for example, here where we have a painter and a family watching them, we create what we call hero animations to kind of break up that repetition and add narrative story beats. So we can do a bit of environmental storytelling there. But as we pan over to the left here, you'll also see that we have cafes filled with people, and these are entirely vertex animation driven. So we've removed the skeletons there and reduced that asset size to allow us to do this at scale and have many things going on at once. So you can see there the combination of these, we layer them in different methods to allow us to get that final pixel. So we know what we need to do. We need to be able to give characters to our clients. We need a set of tools to do it. So we need to lay out just what are the design goals. We need to make this sustainable for ourselves. So first of all, we need a consistent source for these characters, right? There's many 3D libraries out there, but they can be wildly different in terms of their visual fidelity and the topology that you get with them, right? So we need that one trustable source we can use long term. Then they need to be customizable. We need them modular. We work across many different world cultures, so we need to make sure we can dress them appropriately, especially if we're representing certain events. This one, super important, they need to be lightweight. We should all be aiming for buttery smooth frame rates at all times. So we need to make sure for us, working on district to city scale environments, that we can support over 1,000 entities on screen and not be harming our frame rates. And then finally, they need to be animated. So this is kind of a bit of a stigma that ArchViz has had for a long time, where everyone's kind of like posed statues and nothing's happening. And this really undermines the idea of it being real-time and interactive, right? We're trying to tell stories for our clients. We often work with our clients in a conceptual phase. So they want to communicate the livability of a space. Like, how are humans going to interact in this space? So we need to use animation there to help give them some environmental storytelling and do that for them. So there's an elephant in the room here, which is the one source we can get, which is MetaHumans. And how can we leverage them for ourselves? So when we started building this toolkit, it was about 2 years ago, and at the time, MetaHumans was still quite a cinematic asset. They were quite heavy in terms of their memory footprint. But in the last 2 years, especially 5.5 and going into 5.6 like we saw yesterday, they're incredibly more optimized. So they give us a huge wealth of a library to use, but we need different levels of detail to scatter these out for ourselves, right? So for me, when we were trying to map out this problem and how we're going to go about it, it came down to one answer, which was sandwiches. Now, you've got to bear with me on this one, because there is a method and a madness. But basically, I was working late, trying to work out how are we going to do this. And I realized, like, you know, when you're in that kind of that flow state, you've been programming, you go, hey, I haven't eaten in 14 hours. So there I was in like the cold, lonely darkness of my kitchen, just pulling stuff out of the fridge and stacking up a sandwich. But then it made me think, hey, I've got my own modular hierarchy here, and it's interchangeable. And effectively, I'm creating my own lightweight, and it's a very optimized meal, right? So that's where I started looking at MetaHumans. I was like, hey, there we go. They're just the fridge, right? So that's how we work with them now. So we've got the body parts in an interchangeable composition for ourselves already. This is great. They're modular for us, yeah? So you can see you have the torso, the legs, the feet. But then we also have skeletal meshes and grooms that build these up. And within those, they have their own levels of detail, right? So we can leverage geometry script to selectively pull out what we need and recombine it in other places. So you can think about it as the shelves in a fridge, as it were. So with that idea, now we just need to define what's our coverage requirements, like how are we going to assess this at different levels of detail. So for us, in the foreground, super easy answer, just use a MetaHuman. The new optimized ones are excellent. They've got facial animation, so if we want to use mocap or we have voiceover, that can do everything for us there. Their memory footprint is about 1/10 of what it used to be, so they're excellent for that. But where we want to get into those hundreds or thousands of people on screen, we need to optimize a little bit further. So this is where today's toolset comes in. And as we get to the mid-ground, we have a merged down version of a MetaHuman that we create. And this is for our mass entity system and these curated hero animations that we do. What we do with these is now we selectively take those parts out of the MetaHuman, recombine them into a single skeletal mesh. So what we're doing here is we're reducing the amount of scene components, so the amount of transform updates we have per frame, but then we're also removing the amount of bones we have. We don't need this facial rig in them anymore. So we're being selective about that. And then finally, we're going to merge down all of these material IDs into a single texture atlas. So what we do is we sacrifice a little bit of that high-end visual fidelity to get a lot more optimization on the other side. And because they're mid-ground actors, we can make that sacrifice there. And then finally, we have the mid to background. And this is where we move over to vertex animation. So at this point, there is a trade-off where they become effectively non-dynamic NPCs. These guys can't be reactive to what happens in the scene anymore because it's a baked animation. But what this does do, it allows us to take the load off the CPU and move all of this animation over to the GPU, which reduces our asset size, but allows it to run in parallel. So at this point, I think it's a good point for me just to switch us over to the editor, and we can see how one of these tools works. So let me bring that up. There we go. So we're going to optimize a MetaHuman today, and I've got our guinea pig here, the guy from the slides. It's my pal, Bruce. There we go. So Brucey boy here, he's dressed fairly casually, but we need them to be interchangeable, right? We want them to be modular so we can redress them for different occasions. So what we're going to do, we're going to swap out his clothing as we optimize him today. So let's say Bruce is going to go on a hot date tonight, and we need to make sure he's looking good. So let me open up my Scriptable tool palette here. Let's just filter this to Unreal Fest. There we go. So I'm going to open up my crowd optimizer here, and you're going to notice if you've built a Scriptable tool before, my property set looks a little bit different to what you're used to seeing. Now, this is something I'm going to share with you all in this code plugin, but effectively what we've done, we've built a way where we can inject editor utility widgets into that slate panel. Now, the reason for this is the property set for what we need to optimize these is actually quite long. There's maybe 15 different important variables we need to handle, and what we want to do is make sure we give that to them in individual bite-sized chunks. So we took inspiration from software installers. We've all used them before. They're easy to do. Send it to where you want. Next, next, next. Easy, right? So what we can do here, we plug in Bruce as our source MetaHuman. We can put him into a folder. So I'll just throw him in demo. Quick tip, always fill out your tooltips. When you're using file paths and directory paths, sometimes the formatting is incredibly important. So just help yourself by leaving it there and help the user. You can give a version number, that's fine, optional name, and then we have the suffix. Typically, we use this to determine like how these are dressed. Are they Western, Eastern, Middle Eastern? So we can just label him here as he's going out on his hot date. So that's all good there. And we can go into our next step. So this is where we get to the extraction options. And this is what the geometry script is doing for us on the back end. So as we saw, if we look at his body, we have all of these skeletal meshes and different modular components. So what we can choose now is what ones do we want to keep in this process and what ones do we want to omit. So for us, we don't need torso and we don't need the legs. We're going to replace those. Feet are okay. His shoes are all right. The groom, we're going to extract from that. And we don't have an option for face. We've never really run into a reason to not have faces on our people yet. So we get that one for free. And we go into our next step here. And this is where we can now inject optional meshes into this process. So here we have free lists, which is torso, legs, and feet. So this is where we can replace them. But we actually have another one here, which is called additional non-vertex colored, right? And in this process, what we actually do, as we extract the torso, the legs, and the feet, we actually give them vertex color on their mesh. So while we've got them all in their modular components, we color them red, green, and blue respectively. And what this allows is for us to get more mileage out of this character further down the line by being able to vary their color effectively for free through custom primitive data. So let me just grab his new going out clothes, and I'll just plug these in quickly. So we have some nice trousers for him. We have a blazer and a tie, so he's going to be looking pretty good. And then we also have like a little shirt panel here, which is effectively his white shirt. So this is something we don't need to be vertex colored. We want that to stay white at all times. And now there's just the final step here, which is what level of detail do we want to extract from these skeletal meshes, right? So this one, we can leave as defaults, but it allows us to tweak it if we have other versions. And then also the atlas size. So we're merging all of that down, right? So this one, we'll leave at 1024 for now, and I'll send him off to bake. Now what's important here, we have a loading bar. We've all seen it 1,000 times. But this is the thing, we need to build this into our tools. Because I could be here for the next 20 seconds vomiting words to you all, and while that's doing all geometry script, the editor would be locked out and frozen, right? And for your users, you need to know that something's going on. We don't want to be here right now with like secondhand embarrassment thinking like he's just nuked the editor in front of all of these people, right? So what we're doing here, for us as the end user right now, you've got real-time feedback to know what's going on. It's a cancelable operation as well. So this really improves what can be done with your tools. And we've put a way for you to be able to do this for your own tools in this plugin I'm going to share with you all. Now we can see here, as we're done, I've now been presented with a data asset. And this just has all of the things I might need to reconstruct Bruce anywhere else. So when I want to spawn him into mass entity, I can read from this list. Now important note, use soft object references, load what you need when you need it. But we can come over here and we can see now we've got a newly constructed version of this guy, and he's looking sharp and dapper for going out tonight, right? Now, what's important here is if I pull him up from his folder, we can see we've got a new skeletal mesh baked here. And this is what we're trying to achieve. We have one single skeletal mesh now, so we've reduced the amount of scene components. We've removed that facial rig that we don't need, so we have less amount of bones to update on the CPU. And then we also have just one single material ID now, so we've dropped the draw calls there. So we've already got a huge amount of optimization, and all we've done is trade off a small amount of visual fidelity there, but because he's mid-ground, we're not really looking for the very close-up wrinkles of the face here. So as a quick example as well, if I just very quickly grab his body, we can give him an animation. So let me just assign a walk cycle, for example. And we can see here, he's been able to have his skin weights generated for him during this process. So that comes out intact. And with this process now, within a minute, I'm able to generate a new character, and it goes straight into mass entity, and it's ready to go. And this really broke down the bridge for us, where when we first mapped out, okay, how are we going to do this? This could take up to about 3 hours, depending on the complexity of character and all of the other software you have to go through. But now it's a simple button. I can click my way through it. I can carry on talking to you guys, and we can now provide 30, 40, 50 custom characters for our clients within a day, you know? So this really opened up the doors for us, but didn't fully get us all the way over our optimization goals, right? So this is the mid-ground for people who can walk around. They need to be dynamic. But then we need to look at the next level, which is going to be the vertex animation. So let me just pull up our slides again. And let's just talk about briefly what is vertex animation. So it's a technique we're going to use, and we haven't pioneered it. It's been around for years. It's been in games design for ages, and it's really powerful. Well, what we do is we take our animation data from the CPU, and we move this over to the GPU, where it can be a lot faster and more efficient. So an easy way to think about this is we have three-dimensional space. We have X, Y, and Z. or pitch yaw and roll for your rotations. But these are just floating point values, right? These are scalar values. So what we can do, we can map this over to a linear color. They're a matching data set, right? Although it's a color, it is still just floating point values. Now we have it as a linear color. We can use this as a pixel in a texture. So here, we can now store this, cache that in a texture, and that can be loaded onto the GPU, accessed later. So it becomes very lightweight, and it can run in parallel. Now, at this point, that seems quite complicated, and I'm not going to get into everything about it. But if you want to do it too, there's the anim to texture plugin. So if we look back to those questions we asked ourselves earlier, don't reinvent the wheel. Epic's already done it for us. So if you want to use it, I'm going to be linking to a tutorial you could follow to try it out for the first time. But you can just enable this in your project. And if you go into the plugin folder, there's a really useful editor utility that's already there as an example. And that bakes a couple of animations into Mani, so you can see how that works. But what we need to know is the data asset that feeds in and out. This is where all the business happens. So it's really important that you just take some time to absorb the information there. But when we bake bone-based animation for our characters, there's three main textures that we're going to get out. And this is the data we get. So we get the bone position, we get the bone rotation, and the bone weights. Now, we want to construct a modular library around our animation, right? So we need to just get a little bit of a deeper understanding about what exactly are these and what do they do. So if we separate them, we actually have the bone position and the bone rotation is actually just exclusively our animation data here, right? So the way you can think about it is left to right on a line. Each pixel is each bone of your skeleton. And then each line that we go down is each frame of your animation. So the GPU can just read through this in your material, use world position offset, and you can now get your animation out of it. And you can even see it in the texture here. You can see while their colors are very different, they're actually formed the same because of that skeletal structure, right? Now, on the other side of the fence, we have our character data, the bone weights. Now, this is baked, and it's entirely unique to the static mesh that you bake. So it cannot be shared between anyone else. It has to stay unique. Even if you have the same amount of vertices, they may be in a different order. So you get some wild results, and I don't recommend it. It's not very fun. But now we've seen how we can split this data. We need to start building a library from it, right? So with data assets, we can make them lightweight, and we can make these shareable. So for example, we want to, for the animation, we want to take the bone position, the rotation, and there's other useful numbers, like what's the sample rate of our animation? How many bones? The bounding boxes of this animation for calculating the world position offset. We need all of those, but then where can we get that from? Well, anim to texture does it for us. So once it's baked out, in this data asset, there's a bunch of read-only variables you can see there, right? And this is where you can just look at the material and the info categories. You can use this, extract that, and move it somewhere else. Now, the important step here that we did is we want to share this library to many different clients and different assets, right? So we need to decouple this data because you give inputs into this data asset. So that means you have animation sequences that hang in there, and they may not exist in another project. And we don't want dangling references. So we just extract what we need, and then we're going to put it into our library. Great way to make a library, use a data table. So we have it here, and we have our rows, which are named by the animation. We've got our data asset in there. But then alongside them, we put some gameplay tags, right? And we do a little bit of the heavier lifting here to benefit our tools further down the line. So with these gameplay tags, we can now build smarter rules for spawning characters. So rather than just randomly throwing them into a scene, we can create rule-based tools later on that allows us to filter these out. So at this point, we've got our animation library. That's great. We've baked that out, and the anim to texture will do the job for you. We now just have to create the character data, and we need to decouple this. So there's only 4 things you need for a character. You just need to know the source skeleton. This is really important for that animation data to push it to the right data table. So for us, for example, we have 7 skeletons. We have male, female, short, medium, tall, and then we also have a child rig. So we can assign that there. We need the static mesh that we've baked for it, so we want to keep a reference there. You want your bone weights for this as well. And there's also something called num bone weights rows per frame. I'm not going to get into what that is now. Just know that's important to your character, and anim to texture will give you that anyway. So at this point, we've got a good idea of how we can break this structure apart, start creating something that's modular that can work very well for our characters. So if I bring us back into the editor very quick, and we can see in that initial process when we created this animated version of Bruce, we actually also got a static mesh version of it, with some of the hair cards, the low-res hair cards, baked into this character. So he's ready to go into vertex animation now. And opposed to the MetaHuman optimizer, where we had to build it from the ground up, so we have a lot of variables we need to put in. This tool we're just building on top of anim to texture. So we actually have a really simple property set with this. And what we've done is we've actually minimized the amount of inputs you need to do. We can already determine what skeleton or what animation they may need. So if I open our character Baker here for vertex animation, I just need 3 things at this point. What skeleton is it? So I know it's a medium height male. And then I can plug in the static mesh that we have ready for this, and then also the skeletal mesh. And then I can send them off to bake. Our scope slow task is back, and it gives me a moment to drink some water. And again, we have feedback. No one has to panic thinking that I've shut everything down. And we'll just let this finish up. Now, what's useful here is we've had Bruce spawn for us directly into the scene, and you can see he's fully animated already, right? Now, because we knew what skeleton he's going to be, he's already got a data table assigned for him. And let me just see how many animations did we bring for him today. We have brung 31 animations for Bruce today. And this is something that we went through the effort of decoupling this data for. Because when you first start using anim to texture, the examples you see, you get given a list where you can put in multiple animation sequences and they get baked into the same texture. Now, there's 2 limitations we ran into with this. One is, let's say I have 5 animations in my texture and I want to replace the 3rd one. I now have to rebake the whole texture. So it's not the end of the world, but it's a bit of a destructive process. And then the second one is if we want them to have access to a huge library of animations, at a point, we're going to hit a maximum texture size. So instead of us loading large monolithic textures, we'll put them into very small ones, which are bite-sized chunks that allow them to get what they need when they need it. Now, let's say, for example, we've put this in our data table, and we've also organized this with our gameplay tags. So we can see he's sitting there. He shouldn't be sitting. He's on the street. There's no seat. So we can use these tag filters now to selectively choose from this library. So if I just omit the sitting one from the include tag filter, now I'm only going to get standing versions of Bruce. So you can already see how that starts to build a base for us to build very smart tools off of this in the future. Quick side note here as well. I did mention there we give them vertex color. So if I assign a data table to him here, which is this guy, then as I randomize through him, we'll see that we get different color variations of his suit. So this is something that we did the work for earlier in that geometry script process where we gave them all vertex color. And what we're doing here is getting the most mileage out of a pre-baked asset at this point. So for us, at the moment, we're looking at him very closely, but really these characters for about a 10 to 20 meter distance and beyond. So at this point, we can't really see the facial detail of them anyway. But what has the biggest impact on the visual there is the movement and the color of the characters. So this is great. We've got some characters here, and they're optimized, or at least I say they are, right? So we need to now see, okay, are these optimized as much as we need? So if I just pull us out to no man's land quickly, I've got a very simple blueprint here that I'm going to use just to demonstrate that we can do this at scale. So let me just drop this into our scene. And I believe if I use 31 by 31, I'm going to get roughly 1,000 people spawn here. So let me just hit that button, and these guys are going to spawn into our scene for us. So there we go. So we've now got an army of vertex animated people. Now what's important here is we're looking at these people from the distance they're intended to be seen from. But actually, in our inputs, you can see there, we only have 25 characters that are going into this, but we actually effectively have a crowd of 1,000 people that's believable, because we've put the effort into making sure we can vary their color, vary their animation, and this gives us a huge amount of mileage. Now, you may have noticed my computer's not on fire right now, and I have 1,000 people on screen. We're also using Nanite here to get a lot of extra performance where we need to reduce the polygons at a distance. So that's doing a huge amount of work for us there. And this allows us to then work at scale. So that's where we're going to get about 70 to 80% of our coverage, autosave, for most of our scenes. And then where we need the detail, we can now start constructing smart tools out of these. So for example, let's say we need a talking group. I don't want to randomly just spawn a guy and have him like talking to no one, you know, or just doing some weird, creepy stuff. So what I'm going to do is we're going to define a rule set. So as I go in to spawn these people, we make sure the first person is just doing something that someone on their own would do. You know, we're all kind of antisocial these days. We like to text on our phones, maybe take some photos. So we make sure that person on their own is guaranteed to have something contextually correct. But then if I introduce another person, I can now define a rule saying, well, they should be in a conversation now. So someone should at least have some kind of talking animation. And then you can see how we can keep defining rules for these people. But really the benefit here, this means that our layout team can very quickly populate the scene without having to worry too much about exactly what animations are you placing. That's something we can do in the final steps where we want to add some polish. Now, there's another example here, which is where we start to feed it into a PCG system. So there's a really good talk about 2 years ago, actually, from Chris Murphy, who's shown us how to build a forest with PCG. And there's a technique you can use here, which is you can create assemblies from a streaming level. You tag your actors inside of that, and then you can bring that into your PCG graph and selectively change out different elements. So they're effectively proxies for you to put into PCG. So we can see here, with this one, very simply, we need to populate tables and chairs for restaurants and interiors. So I can very quickly just draw these out. You can affect them with the gizmos. But what we've got is very quickly, I've got people seated at tables. They're sitting here. They've got accessories like this guy. Cheers, mate. He's going to drink from his wine glass. But what we've got is very quickly characters in context with correct animations. We can also see here we've got a huge amount of characters on the screen at the moment. And this has really enabled us to rapidly populate our scenes and worry less about just having to do the hard work of every individual placement. So you may have noticed, as I've been talking about it, some of our characters are using props and accessories. Now, this is a little bit of a challenge when it comes to vertex animation. So let me just bring up the slides again. When it comes to vertex animation, like let's say we're making a game. I can run along, I can pick up a sword, and I just attach it to a bone on my hand, or a socket, right? But we've just gone through all the effort of removing those skeletons for optimization, so we have nothing to attach it to anymore, right? So we couldn't really find a very well-documented process of how we might have to go about this, so we kind of had to build this for ourselves. So effectively what we do is we simulate what an attachment would be just by having another vertex animated mesh there. So the prerequisites, if you want to prepare one for yourselves, is you need to bring your asset. Let's say we're going to use a phone in this example. Is you're going to flatten your material IDs. We're here for optimization, so let's get rid of those draw calls. You need a static mesh ready to go into anim to texture. You need a skeletal mesh counterpart, and then also need to have a rigid skin weight binding, so full influence to the bone you're going to attach it to, right? So we've built a Scriptable tool to do this, and in the first steps, what we're going to look at is we need to prepare this mesh. Now, we need to assess things like poly count. Like, I can't tell you the amount of times people have brought me like laptop models where it's like 200,000 polygons and you've got the charger port and all the buttons. Let's put detail where we need it, yeah? And it's very important that all of this animation runs through the vertex shader. So if we can drop the amount of vertices there, we're really winning for ourselves. Now, we need to collapse those material IDs, as I said, and there's a really useful tool you can use already in editor. So if you get the static mesh editor subsystem, there's a function there that says merge static mesh actors. And although it's written as a plural, you can just give it a single input. And there's some useful stuff there where you can get it to merge matching material IDs, but you can also get it to merge down all of your material IDs into one single atlas. So that's what you saw earlier with our characters, and then also what we can do here with our props. So we have a reference skeletal mesh. There's Bruce with his nice little A pose. And rather than attaching this to his geometry, what we want to do is create a proxy skeletal mesh that we can now bake in anim to texture. So this is what our tool does. It's going to run through that cleanup process, make sure it meets our standard. Then we're going to use some geometry script to update the pivot point. So effectively, you want the pivot point at world 0 or your root bone, and you're going to offset the geometry match your target bone. Once you have this, you can now generate a new skeletal mesh asset that you can work with. And when we've got that, we continue on with the geometry script, and then we can apply skin weights here. So all you need to do is give full influence with a triangle selection of your whole mesh, and just give that to the single target bone. At this point, we now have what we need to use anim to texture again. So now we have our skeletal mesh, our static mesh, and there's a reference animation. Now our reference animation here, this is important, this is just a means to an end. We just need our bone weights at this point. So it's a very short animation of a couple of frames, so we're reducing the time it takes to bake. So we throw it through bake anim to texture, and then we get success. We've got our bone weights at the end. So at this point, sure, we could put it into our scene, but we should allow our tools to also finalize and clean up our processes. So what's it going to do? It's going to throw it in a data table. We love our data tables. Then we're going to assign a corresponding gameplay tag so we can look these up in the future. So let's say, for example, we have many shopping bags. They can then at least randomly select them, get some more variance out of it. And then we're going to delete the transient assets. So in this case, if we think back to when we're talking about how this data is structured, the accessory just needs its bone weights. The animation data that we bake that with is completely irrelevant. We can just delete that, clean up, and make sure our projects stay clean and very lightweight. And you can see there in the picture, Bruce is there. He's got his phone. He's looking at the Squint Opera website, having a great time. Now, there's a lot of information there. So if you do want to attempt this for yourself, here's a very quick summary of it. You need to clean up your static mesh, update the pivot offset to match your target bone. You need to generate a new skeletal mesh, so you're ready to go into anim to texture, apply your skin weight, and then run through anim to texture, and we're happy. Now, by doing all of this work and wrapping this in tools, what we've achieved now is being able to share this data. So we have our animation data in the center, and then our character and our accessory can read off of the same loaded resource, which means that we're now reducing our memory footprint and making things very efficient for ourselves. So there may be something you're thinking at this point, though, which is how are they going to stay in sync? Because they're not actually the same character, and they're not attached. So we need to make sure they actually can work with one another. So it's really easy. It's this guy, time load. So in your material graph, you've probably used it before, but if you didn't know, this is actually a global value. So from the moment your editor runs or when you run your application, this number is just ticking throughout. So when your character spawns, like the body and then the accessory, it's going to read off the same time node. You can give it an offset to make sure people aren't fully in sync with each other, and it will always stay in sync from that. So that's super useful for us. And we can see here, if I just go back to our scene, and I go past this horde of vertex animation characters, we can see as we go to our tables and chairs, for example, we've got people here drinking, they're talking to one another, and then we can see here like a guy just ignoring his girlfriend, texting on the phone, like textbook stuff, really. But that's really helped us add a layer of life to these people. So without those accessories, you're really limited with vertex animated characters to they're either talking or they're just idle. And it's kind of dull. It doesn't really breathe that life into the scene. And we want to give context to the areas that we're populating for our clients, give them interactions that are happening. So that really addressed it for us and allowed us to push that over that boundary. So this is kind of where I'd like to kind of stop going through all of the process of what we do with characters, but start talking about what I want to share with you guys that you can implement into your own tools. So the first one I'm going to show you here is probably the most underwhelming tool you're going to see of all time, but I would argue it's very important, which is our slow task demo. There's our old pal, and it just goes through, runs through, and it's just going to cancel itself and run out at the end. But let me just pull up the blueprint for you and show you how easy it is for you to integrate this into your own tools. So let me just open this up here. There we go. OK, so if we look at the top, when we start our script up for the Scriptable tool, you can just grab our subsystem here, the Scriptable Tools starter pack, and there's 3 useful events you need. There's when it's canceled, when it's completed, and when it's updated. Just bind to those, have your stuff ready, and then you can call start slow task, and this is where all the business happens. So what we need to do for a slow task, you have to define how many frames of work is it going to go through. So we give it a list of that, and because we're here for better UX, you're going to give it a list of names. Ideally, the major functions you're about to run through. So once you've done this, it will run every body of work. It's going to report back to that on-task updated event, and it will also give you an integer, so you can track where you are in the process. So for example, you could use like a switch on int, and then you could use this to then call your other functions, like do this, do that, do whatever. This one will just run on a loop because it's just a demo. But then, of course, you also have your completed state, your canceled state, so you can close your task, clean up the operations, whatever you need to do. But this is something that you can take, you can integrate into your tools. It'll take a couple of minutes for anyone that exists. And hopefully that's going to help you just have a little bit more polish on top of your tools, especially being able to cancel out of a long task that may be going on for a while. This could be very useful. It certainly has for me. Now, the other one I want to show you guys, and this one is the one I'm more excited to see if people build some cool stuff off of it, is the custom widget demo. So as we saw with the MetaHuman optimizer, we built like an installer wizard to make things easier. So that way of injecting custom UNG into Slate, we're going to share that with you in the plugin. And this version of it is just a custom mode. So let's say you have a couple of different editing modes within your tool. Then you'll be able to swap out different property sets. And what we're trying to achieve here is just to make sure we're giving them only the information they need to interact with, and they know this information is always relevant to that tool. Now, with Scriptable Tools, you can add an overlay to the viewport already, and we're not trying to supersede that, but the way we break up our information is if we add one to the viewport, we want to use that for manipulating the level and the geometry data that we're looking at. But when it comes to the property sets, our inputs and our outputs, we've been using this a lot now to simplify these processes and make it very easy. So if you wanted to do it for yourself, we have an example here for you. So when you download the plugin, you can look at this, and it's really easy. You just have to get the subsystem, and it's add widget to Scriptable Tool window. So give it your editor utility. That's going to add that to that slate panel. And then it's going to return you a custom widget, or your custom widget. And for example here, in this demo, we've just used the buttons. We've binded to their on-clicked events. And then we swap out the different subtools here. But you can build so many things on the top of this and really start to improve the UX and custom fit it to what your team is and start building some standards about how you want to approach your tools. Now, there's one other one that I'm going to share with you very quickly. And you don't need our stuff to do this. You can just do this today. But you may notice when I had that Scriptable tool open, all of my property sets here have a nice little button that says documentation. Now, property sets are a blueprint class. So if we go and look at our blueprint class, we can implement an interface with this. And we have a very simple example for you here. So if we look at this interface, it has one single function called documentation. The important part here is mark it as call-in editor, so it becomes visible when it's in Slate. Now what you can do is implement that in your property set. And if I pull up an example for you here, there we go. Now you can use this to do something like launch URL. So this is a really useful node where, OK, so if you're on Gdocs, Notion, point them to that. But this can also launch local files for you. So what this can do, you can launch videos with this. And it's going to take whatever the default program is on your OS and associate it to that file type. So you can do videos. You can do audio if for some reason you want to like voice over your docs. But you can use this to do a lot of things. And it's kind of an unknown technique that you can use for this. So you can implement that today. And again, what we're doing here is we're just improving the overall experience of using these tools and making it easier for everyone on both sides of the fence for this one. Because we all know, for the developers in the room, when you slave over that hot keyboard, you write your documentation, and even though it's called a readme, no one reads the readme. So what we do, we make a little button for them there, and we give them everything they need in one spot. So what we've done for them is we've given them a nicer interface. It's easy to use. We haven't cluttered them with information. And we've given them all the guides that they need. So the step-by-steps, more advanced documentation. It's all in one place for them there. So hopefully those things are some takeaways. And as I said, I'll post this stuff onto EDC towards the end of the week. So you guys will be able to download it, try it for yourselves. But hopefully that's been insightful for you all, giving you all some ideas. And just as some finishing thoughts for you all, is when you plan out your tools, always think about your frameworks with a bigger picture perspective. If you can do some of the heavier lifting earlier in that process, so other tools can benefit further down the line, do it where you can. Reuse your resources as much as possible. We want to be efficient with memory management. We don't want stutters. We want those really nice frame rates. So be smart about where we're loading things and if we're repeating the same loads. And then finally, as I've been talking about the whole time, consider the UX of your tools. A tool at its heart should make your life easier. It should be simpler. And if it's making it or taking longer than it would to do it the old-fashioned way, why is this a tool anyway? So with that, I'd like to thank you all for coming, listening to me talk for a while. And I guess we can open up to some Q&A.